Hi ladies, in this video we're going to go over the cosine rule. So in the previous video for 4F we did the sine rule, and you use the sine rule and the cosine rule for non-right angle triangles. So think about your triangles in two forms. You've got right angle triangles, and for right angle triangles you use Pythagoras or a trig ratio to solve for an unknown side or an angle. And for non-right angle triangles, we use the cosine rule or the sine rule. Okay, so which one you use, it all depends on what information you have. Always, if you're a bit unsure, just try for the sine rule first because it's a little less complicated than the cosine rule. And if you don't have enough information, then you can use the cosine rule. But basically, as it says on the first point here, the cosine rule relates one angle and three sides of any triangle. Okay, so basically it just depends on what sides you have. So if you have, here we go, so the cosine rule is used to find the third side of a triangle when two sides and the included angle are given. So that just means if you have angle C, A, and B. So the included angle is just between two known sides, and you'd probably use it to work out lowercase c. So you can see here we got c squared equals a squared plus b squared minus 2ab cos c. And you can rearrange a, b, and c. Just make sure that what side you're looking for, you use the corresponding angle. So the other variations of this are a squared equals b squared plus c squared minus 2bc cos a. So notice how they just switch spots. It's kind of like when you do Pythagoras' theorem. And then the same for b. So I'm writing very small so I can fit it in here. Whoops, don't forget the 2, AC cos B. So you can see if we're looking for length A, we use angle A. If we're looking for length B, we use angle B. Now you can also use the cosine rule, it's just rearranged, okay, or transposed, to find the angle. So basically this second dot point here, we can use the cosine rule to find an angle when given three sides. So I'm going to just erase this so I can talk about it again. So if you're given A, B, and C, we can use it to work out the angle C, or you can use it to work out angle A or B. You just got to make sure that if you're doing angle C, that you write it correctly. Okay, so everything has to go in the correct order. So other variations of that, you could have cos A, so you're finding angle A. You would then have b squared plus c squared minus a squared over 2bc. Or if you're finding angle B, you just got cos B equals a squared plus c squared minus b squared over 2ac. Okay, so the same formula, it's just A, B, and C. Just change. So when you're working with a non-right angle triangle, so for both the cosine rule and the sine rule, so you would have noticed in the sine rule that we the labeling convention of the triangle. So angle A has to be opposite side A. Angle B has to be opposite side B, and angle C has to be opposite side C. So just make sure you label your triangle correctly. Otherwise, it's not going to work for you. All right, so let's have a look at a few examples. Now, when you're labeling your triangle, it doesn't matter what you call A, B, and C. I tend to like just putting A here where your angle is, but it doesn't really matter. It's just a preference. So label your angles first and then do your sides. So we've got angle A, so that means side A is opposite it, B is here, and C is here. Now, just like we did with the sine rule, just label what you have And let's use a bit of colour, oh, black. So angle A is 125. Don't know B or C, so I'm just going to cancel them out. Cancel them, cross them. Length A is what we want. Okay, so I'm just going to leave that as A. You can call it X if you like, but A is fine. If it's given you something here, so if it's labeled it as X, obviously you'd put X here. B is 7 and C is 11. All right, so we're finding length A, so we always put what we're looking for first. So A squared equals. Then you can go up to the cosine rule. So let's see if I can remember it. Cosine rule is one that I never remember. So B squared plus C squared minus 2BC cos A. Let's check. BC minus 2BC cos A. Beautiful. It's always good when your maths teacher can remember the formula. Okay, A squared equals B, so put in 7 squared. C is 11, so I put in 11. Minus 2 times B, which is 7, times 11, times cos A, so angle A is 125. All right, so to get A by itself, we just take the square root of both sides. Okay, so we don't want A squared, we want A. Now, some of you will probably be thinking, when you take the square root, you get the plus or minus sign. We're just looking at the positive because we're looking at a length of a triangle. And your length of a triangle can't be a negative, or the length of any shape can't be negative. So we only want the positive solution. Let's find where my calculator is. So you need to put all this into your calculator. So we've got the square root of 7 squared. So you can do that, or if you don't have confidence, you can just write 7 squared plus 11 squared minus 2 times 7 times 11 times cos, what was our angle? 125. 125. So I'm just going to move my calculator over because you can't see the whole screen. Girls, remember you have to be in degree mode. Okay, and just check before you press enter that you've put in everything correctly. Okay, your angle should be in brackets. So if it's not, it might not work for you. So there we go, 6 point. All right, ladies, I've edited this video. I don't know whether you've noticed a bit of a glitch, but I just noticed in moving on to question 3 that my calculator is in radian mode. Whoops, sorry. So I should have checked, but silly me, didn't realize until I started doing question 3 and I was like, that's not the right answer. And I didn't question any of my other answers. So I was okay with so you would have just seen me do this, 6.98. And then when I checked the answers in the book, I was like, what? So what I should have done is question my answer. So if I have a look here at the triangle for question 2, oh gosh, go away. Everything's glitching. Okay, so this triangle here, which I did in A, the side opposite your biggest angle, so 125 is your largest angle, so A should be bigger than 11 and 7. So your biggest side is always opposite your biggest angle. So A should be bigger than 11 and 7, and I should have questioned my answer of 6.98. So I'm going to rub that out and do it properly now. So where are we with the calculator? Okay, so I'm going to have to change it, and the reason why it went out of my settings is because I restarted my computer and I had it in degree mode and I never checked. So now it's in degree. Okay, so if you're getting the wrong answer like I have, and I'm just going to go back up here, and there we go. There's the correct answer. So 16.07. All right, and I also have to fix this answer over here. So I'm going to have to edit the video again to fix that. How many decimal places do I need to do that to? 2 decimal places. I might go on and do C. Okay, so I'll skip B and do C. All right, so labeling the triangle first. So if you want to, just used to doing the angle as A. All right, side opposite A is little a, then we've got B, and then we've got C. So identifying everything first. This will also help you with the sine rule. So you'll notice if you watch my video on the sine rule that I labeled it like this. Okay, so A is 38, B and C we're not using. Little a is what we're looking for, so I'll label that as little a, and then B is 19, and then C is 24. All right, so always write your formula. That just helps, you remember. I laugh because before I said I always forget I usually forget that too. So probably don't always rely on your memory. So A squared, B is 19, C is 24. So 2 times 19. Oh, I'm going to run out of room. I'll just put it. So I've got room on my page, but the videos. Whoops. There we go. Times cos. What was my angle? 38. All right, so just like we did before, we want to get A by itself. So we take the square root of both sides. And it's the square root of everything. So one big square root. Okay, and then just plug that all into the calculator. I'll move the calculator over here so I can actually see what I'm doing. All right, so we've got the square root of 19 squared plus 24 squared minus 2 times 19 times 24 times cos 38. So 8.12. All right, so girls, I'm not the best at editing videos, but you probably notice I had to change the previous answer because my calculator wasn't in radian, was in radian mode, wasn't in degree mode. So I'm just going to fix this answer here. So sorry for the unprofessional editing skills. So we should get 14.78 for this one. Okay, and that was centimeters. I didn't write centimeters for this one. Okay, beautiful. Sorry about that. Angle. Now, I'm not going to always do A, so let's just now do angle as B. Okay, because I just want to show you it doesn't matter what you label it. So if I call that B, this one A, and this one C. So side opposite A is little a, B, little b, and then C. So label, we've labeled, now write everything down. Okay, so angle A we don't want. B is theta, so we're looking for that. That looks like a clock. It looks like it's 3 o'clock. A is 7, B is 8, and C is 5. All right, so when you're looking for an angle, we use this rule here. Okay, so we got one for the side length, which is on the left side, and this one here that I've just put a square around is the one you use when you're looking for an angle. Now I labeled my triangle, sorry, my unknown angle with B, so I'm going to use this one here. Okay, so cos B equals A squared plus C squared minus B squared over 2AC. Let's see if I can remember that. Cos B equals A squared plus C squared minus B squared over 2AC. Let me just check. I don't want to go any further unless it's correct. Beautiful. Okay, so let's substitute everything in. So the triangle has labeled B as theta, so I'm going to write theta. A is 7, so 7 squared. C is 5, so 5 squared, minus B, 8 squared, over 2 times 7 times 5. Okay, so we want to get theta by itself. So this is just like when we did the trig ratios, inverse sine and inverse sine. So theta now by itself, inverse sine of everything here. And I would just leave it like that. You can go ahead and calculate it, but I think the more you do that, the more likely you're going to make a mistake in copying things down. So there's nothing wrong with just leaving it like that. Okay, where's my calculator? All right, so your inverse cos button. So we go to trig, and then we type everything in. Now you'll notice that I have lots of numbers on the numerator and lots of numbers on the denominator. So you either need to use brackets or you can use this button above this fraction button. So we can just type it all in there. 5 squared, plus, minus 8 squared over 2 times 7 times 5. And I get a very small angle, 1.43. I'm a bit worried, that's very small. I feel like I may have gone wrong somewhere. Okay, I'm going to check that because I don't think that's right. All right, so I did notice, girls, that there was something wrong because 1.3 degrees is very small. So I should have questioned my answers earlier than this, and this is a good lesson. And instead of restarting the video, I thought I'll keep everything in and show you how important it is to check that your calculator is in degree mode. So just going to erase this. Okay, so you would have seen me already edit the other two answers. Again, not the most professional. Okay, so I'm going to just highlight what I did before, and there we go, 81.79. Or how many decimal places do we have to do it to? Okay, 81.79. What was I going to say? Yes, always check that your calculator is in degree mode. Otherwise, and always check your answer. So I knew that answer was wrong, but I should have checked the previous ones as well. Okay, let's quickly do one more. So let's do C. So labeling our triangle. This time let's call our angle C. So I've got A, B here. So A, doesn't matter what you're labeling it, girls, A, B, or C. I just did it that way now just to show you can use A, B, or C. It doesn't really matter. But your opposite sides have to be correct. Okay, so we're not using angle A or B, and C is theta. So length A is 9, little b 14, and little c is 13. So your cosine rule, we're looking for an angle. So I'm going to work quickly because I'm just conscious of the time. A squared plus b squared minus c squared over 2ab. So we've got cos theta. A is 9, b is 14, and c is 13. And then 2 times 9 times 14. And I just want to check that I've got those numbers correct. Cool. Okay, and so to get theta, to inverse cos. All right. Now, just with the, oops, what am I doing? I've got to get the answer. Now, it goes with your calculator. your calculator's probably always in degree mode, unless you're using the emulator like I am on the computer, because my computer restarted and I didn't even bother to check, because I've been using this calculator nearly multiple times a day in degree mode, and I never had to change it. And you would hate to be in, maybe in year 12 doing your methods exam or your specialist exam, and you're in the, or even your further exam if you're doing further, you're in the wrong mode. So we do go into radian mode for the unit circle. So eventually we'll be going between degree and radian. But yeah, you just got to make sure that you're in the correct one. Okay, I'm just going to make sure I've written that down correctly. So 64.6, oops, 2 decimal places, 62. All right, and if you want, you can check that looks pretty reasonable. Seems okay to me. I don't really have time to check it because I've got 2 other questions I want to do. So I've got some worded questions. Question 4, a triangular goat paddock has 2 sides. So we'll just draw our triangle. Now, we're not in art class. We don't have to do it to scale. 2 side lengths, 320 and 120. Oh, sorry, 170. And the angle between them is 71. Find the length of the 3rd side. So let's label the triangle. Let's call it angle A, B, C, this is B, this is C. So A, B, C, then A, B, C. Okay, so angle A is 71. We're not using B or C. Little a is what we're looking for, so you can call it X if you want, or just little a. B is 170 and C is 320. So cosine rule, A squared equals B squared plus C squared minus 2BC cos A. So A squared equals 170 squared plus 320 squared minus 2 times 170 times 320 times cos 71. All right, and we just want to take the square root of both sides. Girls, it's really important that you do show the square root sign, especially if it's a show that question. In marking further exams, if you don't do that square root, you get it wrong. So just make sure you do show that square root. Okay, let's put it into our calculator. Oops, I don't want the whole thing, otherwise I can't see my numbers. Okay, so the square root of 170 squared plus 320 squared minus 2 times 170 times 320 times cos 71. So 309.64. And I forgot about the context of the problem. What are we doing? Meters. Okay, so that looks about right, because 71 is probably going to be your biggest angle. So A will be bigger than 320 and 170. So, and we're working in meters. And I didn't see how many decimal places. That's what I was checking for. To the nearest meter. So 300, approximately 310 meters. All right, last question. All right, so a helicopter on a joy flight over Kakadu National Park travels due east for 125 kilometers. So let's just do north, east, south, west. So the helicopter has gone due east for 125. Then on a bearing of 215 degrees for 137 kilometers. So 215, so we're starting at 0, 90, 180, 270. So 215 is going to be down this way. So it's going down, so for 137, so it's a little bit longer. before returning to its starting point. So there it is. There's no right angle in there either, girls, or you shouldn't assume that there's a right angle. Find the total length of the journey. So we've got to find this length here. So I'm going to call that x. Now we need to use the bearing to get this angle here. The fact that it's gone due east is very helpful. So when you think about that triangle, it's kind of like in here. So this angle here is going to be 270. So if I went all the way around to west minus the bearing of 215, which gives me, what is that, 55. All right, so let's identify our sides. So A, B, C, A, B, C. Okay, so A, big A is 55. We don't need the other two angles. And then side A I've labelled as X, B is 125, and C 137. Okay, so sine rule. A squared plus, oops, it's got to go into Pythagoras then. So A squared equals B squared plus C squared minus 2BC cos A. B is 125, C 137, minus 2 times 125 times 137 times, I don't know why I don't never give myself enough space, cos 55. Now we want to take the square root of both sides, and we'll just plug that into our calculator. Okay, so get the calculator up. Come on, calculator. Okay, so square root 125 squared plus 137 squared minus 2 times 125 times 137 times cos 55. So we get 121.44. I don't know how many decimal places it had to be to nearest kilometre. So 121 kilometres. And that looks about right. So if you look at the other sides, so 125, 137, so and looking at that angle, you'd want something around that. So I'm pretty confident with that answer. All right, girls, sorry about the mix up with the calculator, but instead of editing the video, instead of, I guess, doing the video again, very important lesson to show you that it has to be in degree mode. All right, girls, bye.